Hello students, after you finish chapter 1 and chapter 2 about stoichiometry and atomic structure, we want to continue our lesson with chemical bonding. And for the topic for today is ionic bonds. The learning outcome, you should be able to describe the different type of bonding using dot and cross diagrams, including ionic bonding, covalent, and coordinative or dative bonding. Every atom, in order to get stable configuration, the atom will combine with other atom, and after the combine, then the atom will reach noble gases configuration. Here we have the noble gases elements. First, helium. If we write the configuration in old way, you have the configuration of helium is 2, neon 2 and 8, because the atomic number of helium is 2 and neon is 10, for argon 18, then the configuration is 288, and krypton with number 36, 28, 18 and 8, in the same way until radon. Here, if you notice that helium has the outermost shell electron 2, and then for the rest from neon to radon with 8. So other atoms will combine chemically with other atom to reach the duplet or 2 electrons in the outer shell, and this law we say as duplet. And when they reach 8 valence electron, just like noble gases from neon to radon, then the law is octet. For chemical bonding, there are 2 types. The first is interatomic bonds, and the second is intermolecular forces. For interatomic bonds, the atoms join chemically together to form a molecule or smallest unit of the compound. Here you have one X atom joined with 2 Y atoms to form a molecule. You have here some examples: oxygen, hydrogen, actually O2, hydrogen H2, nitrogen N2, etc. For intermolecular forces, they exist among non-polar molecules that for van der Waals forces or London force. Among polar molecules, that permanent dipole-dipole interaction, and the last is among molecules in which hydrogen atom attached to highly electronegative atoms such as fluorine, nitrogen, and oxygen. That's hydrogen bonding. For ionic bonds, these bonds come from metal and non-metal. The metal atom, they releases valence electrons or outer shell electron and becomes positive ion or cation. But for non-metal atom, receives electrons, becomes negative ion or anion. And then between the cation and anion, there is a force that we call as electrostatic force. Here are some examples of ionic bonds. For sodium, the electronic configuration 281, and then to reach noble gas, then this one outermost shell electron should be cut off here. Then one electron release. Then we have Na plus because the number of proton stay 11, but the number of electron right now, after one electron left, only 10 electron minus. So totally, right now the atom become Na plus or plus 1 positive ion. For Ca with 2 valence electron, then we release 2 electrons. This is for metal, so metal release electron to form positive ion. And for a non-metal, Cl, for example, 17, the electronic 287, then we'll receive 1 electron to become 8 valence electron. After receiving 1 electron minus, then the atom will negatively charge ion because the number of electron right now one more number than the proton. The proton is 17 proton, and then the electron plus 1 become 18 electron minus. So 17 proton plus and 18 electron minus become totally minus 1. For electron in oxygen, 6 in the outer shell, then must receive 2 electron to become 2 minus ion or an ion with charge of minus 2. The other example here, you have magnesium. If I draw the dot cross, then we have Mg with 2 electron and oxygen with 6. So receive 2 electron from magnesium. So magnesium transfer, releases and give the 2 electrons to oxygen. Then oxygen will receive, become 2 minus ion. The Mg become Mg2 plus. So the formula is MgO for magnesium oxide. The other example, here we have Ca with electronic configuration 2882, so releases 2 electrons. The 2 electrons given to 2 chlorine atoms. Why should be 2 chlorine atoms? Because one chlorine atom will only accept 1 electron because the valence electron of chlorine already 7. So to reach noble gas configuration, chlorine just take 1 electron, become Cl minus. Then Ca become 2 plus, and then Cl minus, there are 2. So the formula is CaCl2. This is the way we draw the dot cross diagram for ionic. compound. Here you have another example. What if the inter-atom bond here between sodium with number 11 and oxygen number 8? The configuration 281 release this one to become octet, and then for oxygen also to become octet receive 2 electron and become 2 minus negatively charged anion. Then the Na become Na plus. So the formula of the sodium oxide Na2O, sodium oxide Na2O is with 2 Na, because Na can only give 1 electron, but oxygen should receive 2 electrons, so oxygen need 2 sodium. So how we construct the diagram? So sodium become 8 right now because release the 1 electron on the outer shell. This become Na plus, and then the oxygen also become 8. With charge of 2 minus, and there are 2 Na plus, like this. This is oxygen. So ions happen of the transfer of electrons. Metals transfer electrons to non-metals atoms. Here you have the example of magnesium oxide. Magnesium oxide 2 plus and oxygen 2 minus. This 2 plus comes from the magnesium atom that give 2 valence electrons to oxygen. Oxygen receive 2 to become 2 minus. Magnesium become 2 plus by giving 2 electrons to oxygen. So the formula is MgO. For NaCl ionic bond formation, here you have sodium number 11. So 2, this one, 8, this one, then 1, this. In the outermost shell, only 1, then we'll give to chlorine. Chlorine with 7, 1, 2, 3, 4, 5, 6, 7. We receive 1 in here, become Cl minus, minus 1, an ion. The Na become plus 1 because release 1 electron. Then the formula is NaCl. Notice when you draw the dot cross diagram of an ionic compound, then the positive and the negative will separate but close to each other. So here Na in one part and then Cl next to sodium. Here you have once again NaCl, and here you have Ca2 plus and F minus. Ca-nya 2 plus. You can do the exercise for CaF2 here. And then you have magnesium nitride. There are 3 Mg2 plus and then 2 and 3 minus. You can try yourself. Then the last is, please do exercise. Question 1, page 51 of your textbook. That's all for the ionic bond. We'll continue with covalent in other video.